In our modern world, we use engines of many kinds. Most of them depend on the energy of heat for their operation. Let's look at some of these useful engines to see how they make use of heat energy to do. Here is a locomotive run by steam. This type of engine is not seen very often nowadays. In a steam engine, heat energy is used to change water into steam, which is piped to the cylinder of the engine. Inside the cylinder is a movable piston. The steam enters one end of the cylinder, then the other, pushing the piston back and forth, forcing the used steam out the other end each time. Because of the back and forth action of the piston, this type of engine is called a reciprocating engine. This action moves the piston rod, which turns the drive wheels of the locomotive. The steam reciprocating engine, which is not very efficient, is called an external combustion engine because the burning of the fuel, which produces the heat to make steam, takes place outside the cylinder of the engine. The engine of the automobile is a good example of a reciprocating internal combustion engine. Fuel is burned inside the cylinders of the automobile engine. This cutaway model of a single cylinder will help us see how it uses heat energy. In the carburetor, air is mixed with fuel, forming a fine spray, which passes through an intake manifold to the cylinder. In the cylinder, the piston moves through what is called a four-stroke cycle. During the intake stroke, fuel is drawn into the cylinder. During the compression stroke, the piston compresses the air and fuel. During the power stroke, an electric spark from the spark plug ignites the fuel, which burns and expands rapidly, pushing the piston down with great force. During the exhaust stroke, the piston pushes out the exhaust from the burned fuel, and the cycle begins once more. Intake, compression, power, and exhaust. Every time the piston moves down, the connecting rod turns a crankshaft which transmits power through other moving parts to the rear axle of an automobile. Automobile engines usually have 4, 6, or 8 cylinders. Gasoline engines that drive airplanes may have a large number of cylinders for extra power. For locomotives and other machines that need great power, there's an engine similar to the gasoline engine. That engine, shown here in cross-section, is the diesel engine, which burns a low-cost type of fuel known as fuel oil or diesel oil. The diesel is also a reciprocating internal combustion engine. It is named for the man who invented it, Rudolf Diesel. The cylinder of a diesel engine has no spark plug. During the compression stroke, air alone is squeezed into a smaller space than in the gasoline engine. This compression makes the air so hot that when fuel is injected, the hot air ignites it. The gases created by the burning fuel expand, forcing the piston down, which turns the crankshaft as in the gasoline engine. In a true reciprocating engine, the pistons are attached to the crankshaft by a connecting rod. Here is a simplified model of a reciprocating engine in which there is no crankshaft. Because the pistons move freely back and forth inside the cylinder and have no connecting rod, this is called a free piston engine. When fuel burns rapidly between the pistons, producing hot gases, the pistons are pushed apart. They hit a cushion of compressed air at the end of the cylinder, and bounce together again, compressing air and fuel for the next combustion. The hot gases that are produced rush out through an exhaust pipe past a wheel with many blades on it. The moving gases turn the wheel in the same way that blowing on a pinwheel makes it turn. In an engine, we call this kind of wheel a turbine. It can be connected to other machinery to do work. The piston part of this engine moves back and forth, but the turbine part rotates. Therefore, this engine is, in part, what is called a rotary engine. Some engines, such as this steam turbine, have no pistons at all, but only turbines. This is a true rotary engine. Inside are many sets of blades connected to a shaft. When steam under high pressure is blown against the blades, they turn, and the shaft spins. The motion of the spinning shaft can do work. Often, the spinning shaft is made to transmit its mechanical energy to a generator, which converts mechanical energy to electrical energy. The steam turbine is an external combustion rotary engine. Here is a simplified model of another kind of rotary engine, the gas turbine. This is an internal combustion engine. It has a fan-like compressor at the right that sucks in air and squeezes it into a combustion chamber in the center, where fuel is added and burned. The hot gases caused by the burning rush out to the left through a turbine. By connecting the turbine to other machinery, this engine can be made to generate electricity, run factory equipment, drive automobiles, or turn a propeller. In this case, it is called a turboprop engine. Turboprop engines are used in many airplanes. The hot gases that turn the turbine, which makes the propeller turn, rush out the back of the engine. In a small way, this action helps move the airplane forward, as air, when it rushes out of a balloon, makes the balloon move in the opposite direction. We say the movement of the balloon is a reaction to the movement of the escaping air. While the turboprop engine is really a rotary engine, it is also something of a reaction engine because of the gases rushing out the back. A jet engine is a true reaction engine. The hot gases produced in the combustion chamber of the engine rush with very great velocity out the back. This action causes a reaction, which thrusts the plane forward at tremendous speeds. But jet engines will not work outside the Earth's atmosphere, where there is no oxygen to support the burning of the fuel. The rocket engine is a reaction engine that will work outside the Earth's atmosphere, for it carries its own oxygen supply, or chemicals that can be used as a substitute for oxygen. A rocket engine produces great power, which is needed to attain the high speeds necessary for travel away from the Earth into space. Here is a drawing of one of the special kinds of reaction engines for use in space. The engine would shoot out high-energy particles, which could drive a spaceship forward at tremendous speeds of many thousands of miles per second. But this is in the future of engines. Today, we use three main types of engines to put the energy of heat to work for us. Their names should help you remember how they work. Reciprocating engines have pistons that move back and forth inside a cylinder. Rotary engines have turbines that spin at high speed. Reaction engines move forward as a reaction to the rapid movement of gases or other particles being ejected to the rear. Reaction engines are the only ones we know of that can be used for travel in outer space. It is exciting to think how important engines are to us now, and how important they will be in the future as man uses engines to help him explore the universe.